I'd like to welcome everyone to our Earth and Ocean Sciences weekly seminar, and it gives me a distinct pleasure to introduce Professor Orrin Pilkey. I get the opportunity to announce that Orrin's 75th birthday is tomorrow, and Orrin at 75 is still fighting back those forces of evil, so I think that's great. So normally when I introduce seminar speakers, I'm standing up here with a piece of paper, and I'm sort of going through everybody, their educational, the degrees they've attained, and their list of contributions and their accomplishments. But as impressive as those are for Orrin, what's even more impressive is the character of the man. So Orrin, I think, sets a great example for all of us who have the luxury in academia because he's really passionate about his work. I think he's really passionate about his work because years ago, Orrin decided to work on something that he's passionate about. And so I think that sets a great example for all of us. Not only is Orrin passionate about his work, he's also tenacious or tough as nails, or other people might have other adjectives for him in that regard. Tenacious, Orrin's also one of the most generous people I know. He's been very generous to his students, he's been generous to this department, and I've also appreciated his personal generosity to me. He's a very loyal member of EOS, very loyal member of the university, and I think that's great. I've known Orrin now for 18 years, and almost every conversation, after those conversations over the 18 years, I walk away thinking, I should be more like Orrin. I'm not there, and I don't think I'll ever get there, but at least I think it's a good goal to have. So, Orrin, welcome.
I think you're exaggerating a little bit. This is our problem. This is a 1960 photo. And this is what it's like in 2000. That's a photo taken from almost exactly the same location. This is our biggest problem regarding sea level rise. And this is another example of the problem. This is a scene on the Olympic Peninsula in Washington State on a beach appropriately named Washaway Beach. I took this on a typical rainy day, foggy day in the Olympic Peninsula, but those are all pipes that for water wells and from an artesian source from houses that have disappeared. So there are 4 houses that have disappeared here, and I was standing on another house that was had already fallen down on the bluff. Pretty spectacular. Well, this is my parents' house, retirement home in the 60s and early 70s, and they got severely damaged in Hurricane Camille. The house had 4 feet or 5 feet of water in it, and but then along came Hurricane Camille, and the house disappeared. This is a picture after Camille. The Hurricane Camille was why I got into the business that I'm in. I got so excited. I used to be an expert on abyssal plains, and I suddenly decided this was much more exciting than abyssal plains. And this is a house, a site of a house in Waveland, Mississippi, right on the beach, that I happen to know because I'd been there for Camille, that the house had been destroyed in Camille, then it was destroyed again in Katrina, and now it's for sale for $700,000. That's societal madness. This is the Gold Coast, where that's the highest building that I know of on any beach. It's about a quarter of a block away back from the beach. It's 85 stories, plus or minus 3. It's hard to count standing on the beach and count that many stories, but it's close to 85. Storms are what ultimately take away our towns on shoreline, and it's been happening for some time, quite independent of the sea level rise. I'm particularly fascinated by Edisto Beach, South Carolina, where this is a community of the rich. This is not a working community. And the wealthy of Charleston and Edisto Beach used to come here, but after the Civil War, of course, the wealth disappeared, and the town, and as did the town. This is not a photograph, but a drawing showing people strolling up and down the beach in their formal clothing, and this is what Edisto Beach looks like today. And the old community is about a quarter mile offshore here, and so the final blow to them was the so-called Great Sea Island Hurricane, which occurred in 1893. going around, whoops, looking, oh dear, looking at, what did I do?
Just click.
This is Bangladesh, the Ganges Brahmaputra river delta. This is below this meter, the 1 meter contour interval, are 15 million people. And this is Shishmaref, Alaska, the village of Shishmaref, Alaska. This is right on the Arctic Circle. The Arctic shorelines of Siberia, which are many thousands of miles in Siberia, the coast of Alaska, above the Arctic Circle, the northern Canada, Norway, and so forth, they all have the same thing. Besides the rising sea level, they also have melting permafrost in the beaches, which makes the beaches easier to erode. And they have longer summers, ice-free summers. Here, Shishmaref, the summer used to be 4 or 5 months, and now it's 6 or 7 months long without ice. And this brings them into the storm season, which gets in October, November. So putting all three of those together, and they're in trouble. This is a photograph taken two years ago in February. The plan now is to move this village. It's one of the few subsistence villages left in America, and they are going to try to move it to the mainland because of the erosion problem at a cost of $300,000 to $400,000 per individual. That's a lot of money. That's for 550 people, and most of the young people want to get out of there. So, but it's what are you going to? Is it, it could never pass a cost-benefit ratio in the lower 48. But is it worth spending this money to save our subsistence societies? Lots of evidence of sea level rise. This is a piling, a bridge abutment in Miami, and you can see the different. Somebody accidentally took 2 photographs of this over a period at different times. And Hal Wanless, a geologist at the University of Miami, discovered these photographs, and he went back to take more photographs to see what had happened since then. But the species had changed, so he couldn't continue this kind of sea level curve. One of the biggest lines of evidence, most important lines of evidence, I think, today that sea level rise is impacting on shorelines is the narrowing of barrier islands. This is a Frisian island in Germany. I couldn't find the name of it, but this is from a postcard, which is pretty neat. You wouldn't see this postcard in the U.S., I don't think. They're slightly different scale, but it's clear that these islands are narrowing. This is happening all over the world, including for coastal plain islands. And this includes the Outer Banks of North Carolina, Santa Rosa Island, and Mississippi, or Alabama, wherever it is. And I think this is the first sign of substantial change due to sea level rise. Another sign of sea level rise are these fringes of dead trees that you see along Pamlico, Albemarle Sound, and also on other estuaries in North and South Carolina. We think that those trees have been killed in part because of rising floodwaters, not necessarily salinization, but rising level of water that kind of drowns the roots and makes it impossible for their survival. Kilimanjaro is cited as evidence of global warming. Not that we need much more of that, but this is the highest mountain in Africa, and it's in the tropics, which makes it particularly interesting. Here is the town, the Brownwood subdivision of Baytown, Texas, in which the sea level rose 8 feet since 1951. And it rose 8 feet because of taking of water by this oil refinery here, and which it took water out of collapsible formation. At one time, there were 300 houses here in this 500-acre subdivision. Almost all of them were removed except for some of the cheaper ones here. Now they took out all the concrete roads and all the lamp posts and everything, and they now made it into a salt marsh with some picnic facilities. So. And this kind of a confusing picture. This is the Muir Glacier in Alaska. This is 1941, and this is 2002. This photograph in 2002 was taken by Bruce Molney, our graduate and also an adjunct professor in this department. But you can see the rather dramatic change here. if all the glaciers in Alaska were to melt, we would have 2 inches of sea level rise. If all the mountain glaciers of the world would melt, it is estimated, not by me, but estimated that we would have about 1 foot of sea level rise. And just for the heck of it, this is a long recognized change in the summer ice cover of the Arctic Ocean. What this slide doesn't show is that on average, they say that the ice on the Arctic Ocean has lost about 40% of its thickness. And here is Greenland with showing the difference between the 1992 and the 2005 zone of melting. This is one of 3 major ice sheets on Earth, and this is the one that currently is probably providing most of the water for the ongoing sea level rise. This is water going down the Moulin. They recently have determined that this water is actually lubricating the ice when it gets down to the bottom. It actually gets into the gravel and makes it easier for the glaciers to move in a seaward direction. In the Antarctic, we have a different situation here. This is we have the West Antarctic Ice Sheet is the only part of the Antarctic Ice Sheet that we're worried about at the present time. The East Antarctic Ice Sheet seems to be, although it's losing at its edges, it seems to be gaining about the same amount in the central part of the continent. But here, there is a significant net loss. The problem with trying to predict the importance of the West Antarctic Ice Sheet is that it's not melting, or we don't think in the future it's going to necessarily melt in any relationship to CO2 content or global warming, because of 2 things. One of these ice shelves here, these are the big ones, the Rhone-Filchner and the Ross ice shelf, and this is the Larsen ice shelf, which just collapsed. That was on the Antarctic Peninsula. That didn't do much, but what they think will happen here is soon when these collapse, and they presume these are floating ice sheets, and they are 200 to 400 meters thick, usually around 200 meters thick. So they're pretty susceptible to breaking up. And when they break up, then the glaciers, right now they're damming the glaciers, holding them more or less in place. But that damming effect will disappear when they break up. A second problem is the grounding of glaciers, which is not well understood. But as they begin to melt, they will become ungrounded, and presumably then will start flowing at a higher rate. This is the breakup of the Larsen ice shelf. The actual breakup occurred, although we were preparing for it for years. The actual breakup occurred in a matter of weeks. I think in 2002. Don't quote me on that though. This is just to put things in context, which I think everybody knows this. This is a kind of a cartoon of the changing temperature since the post-Cretaceous, or the last 80 million years. We are clearly in a period of considerable global cooling. The overall picture is. Some of these numbers here are pretty fuzzy, but that's probably a good general picture. The best evidence of sea level rise by far are the tide gauge observations, which go back a full 100 years. There are all kinds of complications with tide gauges. For example, when they're in estuaries, if you dredge the entrance to an estuary, you might change the amount of the tidal prism, which would change give an apparent sea level rise or a sea level drop. So there's a lot of funny things here. So if you want to do this, you can look at it this way, and end up with, if you can believe that, not everybody believes it, you can see a 3.2 millimeter per year sea level rise, which is exactly what the sea level rise that we now are getting from satellite observation. Satellite observations only began in 1993. So we still have it'd be nice to have a much longer record, but now the last part of the tide gauge curve and the satellite observation come up with the same number. This doesn't have much to do with anything except that it shows putting it on this scale, it really shows rather spectacularly how the carbon dioxide has increased since, just in the last few decades. The Intergovernmental Panel on Climate Change, the IPCC, here are their predictions. They predicted that, I put this in inches because it came out of this book that I wrote, which is available for only $20 or something. Since I'm dealing with real people here, I put it in inches. They predict 7 to 23 inches, not counting the melting from the ice sheet. But I'll talk about this more. And they do note that recent field observations indicate the ice sheet melting has increased, and that appears to be a pretty mild understatement in view of recent studies. But the IPCC, which I admire and I think they deserve the Nobel Prize, it's a group of scientists who are involved with the public in a political way. It's a committee of 2,500 people trying to come up with some conclusion in a very political context. So they did very well. But on the sea level rise thing, many people, some on purpose and some inadvertently, interpret their prediction as being 7 to 23 inches by the year 2100. But it's 7 to 23 inches, not counting the ice sheets, which is a rather major misnote. And here is between 2001 and 2007, the estimates dropped. The reason the estimates dropped is but you have a very hard time finding this. I actually read the sea level rise things of both 2001 and 2007, which is a heroic task. It's very, very difficult to read. Even the little thing put out for policymakers I found very difficult to read. But at any rate, and I knew most of the big words. So, at any rate, in 2001 they included the Greenland ice sheet. In 2007 they took out the Greenland ice sheet. So you're comparing apples and oranges. And but people are mistaken. I just saw a thing just this week from a Puget Sound group that's arguing that sea level rise is not important, and they said, we can see that the sea level rise is dropping between 2001 and 2007, and if it continues to drop at this rate, then we can expect a sea level rise in Puget Sound of a few inches. And so people are using this kind of not exactly misinformation, it's misinterpretation. But I read it and I never found
that
it.
That group at University of Washington, you mean they're talking about the sea level rise isn't important for Puget Sound?
Yes,
right?
that's true. That's true. Yeah. But if the sea level rises 3 feet, it's going to rise some more than a foot or so in Puget Sound. Who knows? You're right. It's obviously the sea level rise is different in different portions of the world and in different situations because of other things such as subsidence, which I'm not talking about. But so in the 20th century, the IPCC says thermal expansion was a big thing, and in the 21st century, they've kind of tentatively said Greenland is, but most people now believe that the West Antarctic ice sheet will be the big player. So we're reversing things considerably. Now there have been a number of task forces since the IPCC didn't estimate what the contribution from the ice sheets would be. Somebody has to. So there are a number of panels in various states. We have one in North Carolina which had just started up about a month or two ago. But this is the one from Miami, the one I kind of like the best because they went into the most detail. This is what they say the contributions are going to be, and this is their estimate. They say in Miami we should expect a 3.3 to 5.0 minimum, and they emphasize minimum sea level rise by the year 2100. Hal Wanless was the chairman of this commission, and he wanted very much to make this 7 feet, but he he was outvoted. Here are what some other people are looking at. Other panels. Rhode Island, essentially the same thing. California, I think I should have said maximum. I think this is the, depending on what panel you talk to, but I think they're looking at a maximum of 4.6 feet. And the Dutch are assuming 2.5 feet in the next 40 years in the design of their dams, of their gates. And Pilkey and Young in this $20 book are a minimum of 3 to 7 feet. And the significance of this for us is we're on, our coast is part of a 3,500 mile barrier island chain that goes from south shore of Long Island to the Mexican border. That barrier island development is done for, gone, toast, unless you build massive seawalls around all sides of the island. The erosion rates and other things will be, doesn't matter what the volume of sand in these islands is, there's no question this is the end of barrier island development as we know it. So 3 feet is a very serious number. It's a little less serious on the west coast. This is an atoll, and this is the lagoon side of the atoll, and where the tide is essentially negligible, at least in this one. And it's about 3 feet from here to here. That's a genuine house. The atolls are the first to go. Already, some of them are being abandoned. Tuvalu is being abandoned. New Zealand has agreed to take them after Australia wouldn't do it. And the Marshall Islands are looking for places. The people are looking for places to go now. What's the one in the Indian Ocean? The Maldives are talking about. The president is talking about buying a chunk of land in Sri Lanka or India, and moving the whole country there to this new chunk of land. I don't think that'll work. But anyway, it's not just sea level rise. It's salinization is a big thing. For example, on the Marshall Islands in Majuro Atoll, in the town of Majuro, they are now growing their crops in 50-gallon drums, abandoned from the Japanese and the Americans during World War II, and they're putting soil in there and growing their crops. This is a one measure of the relative risk to sea level rise was made by a group, can't remember the name of the group, but it was a French group, got a French name, and it estimated the risk based simply on the amount of property that will be flooded by let's say a 3-foot sea level rise. I think they used 3 feet, and it didn't take into account storms or waves or anything like that. It didn't take into account whether the society is wealthy or not. It just looked at the amount of property that would be flooded, and Miami tops every list on the sea level rise risk. And Newark comes in not very far away.
Or it's the area that will be submerged, or like the cost, or like the you get the number of people displaced, or like the total financial cost of that area.
No, there's nothing like only the area that will be flooded, and only the value of the properties. If you have 2 inches of water, 3 feet, then that property is considered, gone. I mean, obviously, Miami is going to do something about this. And obviously, New York is pretty far along in their planning. This is Miami, and if that isn't impressive, the elevation here and the amount of property that's ready to be flooded. Miami, and particular, and Florida in general are the most backward state in the union by far in terms of planning and doing things that are going to like we have in Florida. We have hundreds of miles of high rises along beaches. Well, what are you going to do when the sea level rises? Then you're going to move them all back. Well, of course you can't do that. But other states are far more enlightened. And although this panel from Miami was a very good panel, there's no evidence that it's being taken into account. Rhode Island, on the other hand, has said all future development must take into account a possible 3-foot sea level rise. Now, whether they'll really do that is another thing. But
well, Central Florida is only 3 feet higher.
Is what?
Only 3 feet high.
Yeah, well, the map showing the flooding of Florida is pretty impressive, to put it mildly. This is Dauphin Island, Alabama, right after Hurricane Katrina. This island they've been wiped off so many times, and we keep pumping sand back, and all this sand back here came from as a result of Hurricane Katrina, as the island was actually migrating. But Corps of Engineers bulldozed it all back to the beach. But this is these kind of communities are going to be gone. In fact, this community may be gone already. There's some thinking that maybe we've spent enough federal money here, and so on to other things. And this is the title of this thing should be Societal Madness. This is look at this building. It's being built probably extending just beyond the high tide line. Now, Florida politicians will tell you we have a setback line, but in fact they don't have a setback line. Or, if you have a setback line, you don't enforce it, then you don't really have a setback line. But it's hundreds of miles of shoreline like this that make it impossible for Florida to respond to the sea level rise. Well, I've already said this. It's not just the flooding. It's salinization. It's the penetration of storms and storm surges, and the loss of infrastructure. The mayor of Charleston, South Carolina, says the reason they had to replace their very old stormwater runoff system was because of sea level rise. Already at high tide, the city couldn't drain the Charleston Peninsula. So, well, here's what could be done on I'm not going to get into this. It's not the main part of the talk, but we could, if we got to do something right now, we damn well should. We should immediately halt high-rise construction, and we should, and a gentle way to do this, to move people back, is to not allow people to build houses after storms. Both South Carolina and North Carolina have such laws, but they are never enforced, because after a storm, everybody feels sorry for the folks that lost their houses. I think they're fools for living next to a beach, and we should stop government support of development, and that, including the Stafford Act, which allows the federal government to step in immediately after a storm. And here's upping the ante a bit. Here, this is a gate, one of the two major gates in Holland that show that are there to prevent. They are there now to prevent storm surges, but they have been. One of them was designed with a sea level rise in mind. The first one, though, was not designed with the sea level rise in mind, which is kind of strange, because the Dutch, if anybody, are conscious of the coming changes, both in riverine changes and the rising sea level. They are far ahead of everybody. This is in Colombia, South America, on the Pacific coast. This house is being flooded, so they're taking it apart, and they were built this way on purpose. These panels here can be taken off and carried by two men to a new home site. And the same kind of situation exists in other developing countries, such as on the Niger Delta, where they have houses that are easily moved away by piece. Be careful with mathematical models. This is a statement by Warren Buffett. Actually, he was talking about economic models involving human behavior. But many of our models including about global warming, involve human behavior. How much CO2 are we going to produce? Are we going to be able to, down that number? But I look at it this way, in a crude sort of way, and this is, I got this kind of from Peter Haas. This is quantitative models. We're seeking a number, and in qualitative models, we're seeking an understanding of a process. I think quantitative models are pretty questionable, global warming models, and I'll give you an example in a second. But qualitative models, on the other hand, have been proven to be very useful. In fact, critical to our understanding of global change. One example of a model failing, I think, is the question is, why didn't the IPCC consider the West Antarctic ice sheet to be a factor in 2001, and in 2007 suddenly became the major factor? And the answer is there was a current model that was widely believed that showed that the warming waters made sense. The warming waters would increase the evaporation and would increase the snowfall in the interior of the continent. But it didn't work out that way. And in fact, the model could not have been valid to begin with for the reasons I've already discussed. There are problems that the ice, the floating ice shells are part of the problem. That's unpredictable. The grounding of the ice sheets is part of the problem. That too is unpredictable. But this is an example of the use of a mathematical model that in effect damaged our alertness to the problem. Then we have the Brun rule, which I've written so much about. It's in this wonderful book here called Useless Arithmetic. I have it's available for $18. And I have the Brun rule is the most widely used mathematical model in applied coastal science. It is still being used, but yet it has no relationship to reality. And if anybody wants some papers I've written on it, if you email me, I'll send them to you. Or you can buy the book. That's even better. Anyhow, here are an afternoon of Googling, and I came up with these countries are places where the Brun rule is being used. And to bring it closer to home, there's a proposal now to North Carolina Sea Grant that's being floating around from an engineer. From an engineer, and they are proposing to use the Brun rule in North Carolina to predict shoreline erosion in the future. But it ain't gonna work. Why is the Brun rule continue to be used when it doesn't work? And the answer is, it's the only game in town. The philosophy behind that, part of our problem is we insist on having a quantitative approach. Models are almost holy in some way. The skeptics. It's pretty interesting. The skeptics some of them are pretty colorful. One of the statements that's often made, you've all heard it, I'm sure, is that since the Earth is cooling since 1998, and the way they came up with that conclusion, they decided to draw the curve from here down like that. And when you look at it that way, it is cooling if you count, 5 or 6 years of data. But that's a trick. That's a trick made that the bad guys use, but the good guys use this too. Look at this final curve here. They started here on a low point to come up with to draw a line there. Is that legitimate? But the thing that does give this credibility is that this 3.2 millimeters is the same as the same number that the satellites are finding for global sea level rise. So that gives this approach some credibility. So it's okay if the good guys do it. The disbelievers, I don't know whether you can read this in back or not. Richard Lisbon is the most prominent, the most distinguished of the disbelievers. He is a member of the Academy. And this particular statement, Greenland Ice Sheet is growing, which is forcing the glacier to move seaward, is not true in the eyes of most people. Most people are studying it. Glenn Beck, well, we all know Glenn Beck. What's happened with the Al Gore movie is that Al Gore said something about how it would, I think it was the Greenland Ice Sheet melting would produce 20 feet of sea level rise, which is true. And the West Antarctic Ice Sheet would produce, if it disappeared completely, would produce 16 feet. So, but they take his statement to mean the sea level is going to rise 20 feet in 1 year. And that's why they come up with these statements here. William Gray is the guy who predicts, usually quite unsuccessfully, the hurricanes each year. Niels Axel Morner, fantastic guy, really interesting. I can't understand he until 2003, when the membership got really angry at him, he was head of this commission on sea level rise of all things, and he went to the Maldives and made a study there, and he concluded that the sea level was dropping, that it wasn't rising, even though the country is very aware of the sea level rise. They have built up the elevation of two of their atolls in a very big sort of way. This is a big country. There's 100,000 people on these atolls. So, well, he says that the reason the sea level is dropping there is because of extensive evaporation on the nearby ocean from the warm weather. Anyhow, the problem with this guy and the problem with Richard Lindzen is they must be refuted by fellow scientists. They must be refuted by you guys or by me in order to point out the error of their ways. This is another reason that we and you need to get involved. I'll read this one. Now, if we're going to exaggerate, let's exaggerate properly. Sea level is going to rise not by Gore's 20 feet, not by Hampton's 246 feet, but by 2,640 feet. There goes Andy Revkin. Anyhow, this is Christopher Monckton, who's a major opponent. He was the science policy advisor to Margaret Thatcher, and he's very loud and pretty sarcastic, as you can see from that upper part there. This is another really, I think, a pretty serious problem that we have, those of us who believe that global change is upon us. The New York Times had this headline in 1975, and that's probably the source of the belief that scientists at one point in the 70s and 60s believed that warming that we were about to go into a cooling period, and now it looks like we're going into a warming period. The first warning to our Congress was by James Hansen in 1988. To put this into context, so what they're saying, the opposition saying, is that scientists were off base then when they said it was going to cool, and now you say it's going to warm, so why should we believe you? It's just the temperature just going up and down. This is my favorite. This was Holly Fretwell. That's the name of the woman who wrote this book. It's for 6th grade, and it's available in Barnes & Noble right now. I bought my copy there when I read it with some shock. This is what she says, that the melting of the ice sheets won't raise sea level. She's off by 220 feet. If you do go to Barnes & Noble, you'd be better off buying my book. This is but imagine, this is for the 6th grade, 6th or 7th grade type level thing. Just unbelievable. Then there's another thing. I think we're going to hear a lot more from this. This guy's very sharp. I met him. I had dinner with him one night. He's very charming. But wow. He's at the Pennsylvania's Wharton School, and he, in several statements, he said of 650 references used in one of the IPCC 2007 chapters, no one satisfied the principles of evidence-based forecasting. Well, evidence-based forecasting is a list of things. It's a list of 140 things that, if it was a little lighter, I'd read it. But they're basically a motherhood and apple pie kind of thing. You know, it says things like make sure that the policymakers know what you're going to do ahead of time, and if possible, go at it with two different methods and so forth. But this is something that scientists have never heard about. So why should we care? Well, this Scott Armstrong was hired by the state of Alaska to evaluate the U.S. Geological Survey's studies of polar bears, and he did evaluate the studies of polar bears, and he found that they completely violated the principles of evidence-based forecasting, which, of course, the scientists that did the study had no idea what they were. And I can't figure out how he knew anyhow, because he didn't talk to the scientists. But And the state of Alaska used this evidence in its argument with the Department of the Interior to to not put the polar bears on the endangered list. Armstrong didn't win that one, but we'll hear more from him. My solution for those who are not scientists, you guys can evaluate these things when you read them yourself, but a non-scientist, I argue they should follow the principle of guilt by association, and anything published by these and a number of other foundations and institutes and so forth should not be believed. These guys are not seeking the truth, or they're seeking the truth in a different context than most scientists would seek the truth. And sometimes they do speak the truth, but you're safest to believe things that you hear from researchers in Science Daily and things like that, which is a website for non-scientists with simple explanations of articles in Science and Nature. But so follow the principle of guilt by association. Okay, my final message here is that first of all, you guys are just coming into this field at the most exciting imaginable time. This is, our climate is changing. Big changes are occurring on the Earth, and you guys, in one direction or another, are going to be heavily involved in this in the future, and it's going to be a big thing for society. And that's so satisfying to be doing something for society. I know that because for first 15 years of my career, I was studying abyssal plains and didn't seem to be doing much for society there. And then when I published a little book called How to Read a Beach, or How to Live with an Island, can't remember the name, I got so much feedback, so many people called, they were so impressed, and nobody ever called me about abyssal plains. I really admire James Hampton. He's my hero, even though he's too much of a believer in models. He says, in my view, that 350 ppm CO2 is the point of no return in terms of many effects of global change. Of course, we're now at 385, but nonetheless, except for his a little too strong acceptance of mathematical models with a quantitative single point number, I think he's just amazing. He's been my inspiration for a number of years. He recently, my son who lives in Tennessee, told me that Hansen recently got arrested. He was protesting something to do with the coal industry. He's very much against coal power, and he put a sign out on something, and the police arrested him for littering. Anyhow, I really agree with this statement that that we should speak out politically as part of our responsibility, and the idea that we can just do these things and sit back and impress the dean with publications and so forth. Things are much better now for you to speak out, because when I started, when you spoke out, you had to wait until you had tenure, and because speaking out was almost it was just not appropriate thing for scientists to do. But now that's changed dramatically, and I think we can expect it to continue to change, and that you will be rewarded for speaking out. Working with engineers. In my thing, I work with engineers a lot, and it's a dreadful experience. But I'm slowly beginning to learn why the huge difference in the mentality of scientists and engineers. One way to explain it, there's a seismologist at Northwestern University that has a sign on his door that says, Office of Earthquakes, Volcanoes, and Engineers. And I think that says a lot. He views them, as I do, as pretty damaging to our society in terms of our response to sea level rise. The engineers are doing what the local people want. They're building seawalls and things, but they're not helping. They're not doing the right thing for society as a whole. Okay, let's see. This is This just happened a couple months ago. Duncan Heron was involved with me on this. We worked with a guy down in Edisto Beach, and he's chair of the local beach nurse committee. He's very honest, a bright guy, a long-term IBM executive, and we were opposing some consulting engineers. A long story. But the consulting engineers come up with these big, thick reports that are really well done with color diagrams and tables of vast amounts of data. And we didn't have anything except emails, often with misspellings in them. But then we found out we basically lost. We got flicked off the table like a dead fly. What we found is that we talked to the guy after he basically. We thought that we had the scientific truth, and that the other side was flim-flamming them. And I believe that right now. They were suggesting periods of beach nourishment. They were saying the beach nourishment would last for 10 years or more. For beaches that we were sure would last within a year, would disappear within a year. They said you could mine the inlet, okay, no problem. Well, no geologist believes you can mine inlets without cutting off the sand supply somewhere else. But he took it to be just two different opinions. There was no flim-flam. They're just two different opinions. We never could convince them, the panel. And so they really wanted to nourish the beach anyhow. So it's not up to us, however. It was not up to us to make the decision. It was their decision, that's for sure. But we wanted to present the side, here's what will happen if you nourish the beach. Here's what will happen if you mine the tidal delta. That's what the scientists roll with. Anyhow, so this guy did not understand or would not accept scientific truths. And this happened just last Monday. I was in New Bern at a meeting about terminal groins jetties that we're planning to build in North Carolina. And this individual, a Brunswick County commissioner, said scientists are a special interest group that is disenfranchising the voters. That's the way he looked at us, and that's the way a lot of politicians at the coast look at me and my fellow coastal scientists. And I'm sure it's the same in all these fields where scientists are involved in something where we're trying to tell the public that if you do this, it's not a good thing. It's up to you. Do whatever you want, but let us tell you that if you put in a wall here, you're going to create erosion down drift. But this guy wouldn't accept that as a scientific opinion. He felt that we were an interest group, number one, and number two, that we were simply working against the voters. We're working against the will of the people. Well, that's true. At the coast, we probably were, but in terms of the whole state, we were probably working for the good of the voters. And my final slide here is a slide that Rob Young, my co-author here, found. This is the diagram on which billions of dollars of engineering work was going to be based. This is a diagram that shows the relationship between the miles of storm surge of salt marsh and the reduction of storm surge as the hurricane moves over the salt marsh in the Mississippi Delta. Well, first thing you see is that line. Obviously, that line was just drawn in there randomly. And then if you do draw in a statistical line, least squares, regression line, the correlation coefficient shows that the relationship is insignificant. And then there are several other things that were obvious from this that I'm not going to get into, but the assumption was that if we do things like divert the Mississippi River and build up more salt marsh, that we're going to stop the storm surge, and that's a way to protect New Orleans and a way to protect some of these other communities in the lower delta where the sea level is rising at about 4 feet per century as opposed to 1.5 feet per century right here. Well, the point to be made here is not the diagram itself, but the fact that this should never have been published in the scientific literature. In fact, Rob hasn't published this. This is far too important. If, for example, let's say we wanted to publish this and point out the problem with this and other things, it would take us 6 months to write the paper, 6 months to have it reviewed, and say we go to the Journal of Coastal Research, the best journal for this sort of thing, and it would take a year and a half to 2 years to get published. So it could be 3 years before this is published, and then it wouldn't even be noticed by the right guys. So this is a case where the only reason to publish this is to make the dean happy. There's no possible reason that this should be in the technical literature. It should be in the newspaper. It should be given to all the panels, in which it was, that are looking at this situation in the Mississippi Delta. Just spread it as far and wide as you can. Often that means you don't get credit for having discovered this, so you have to swallow a little pride or something. But and you can still publish and still keep the dean happy. So it's something to consider. This is a different kind of science that has an immediate need. I would say once again that you guys are in the most exciting time. This is the most exciting time in my science that I've been in all these, God knows how many years, 40 years here at Duke, and I think you guys are coming in just at the right time. What you're going to do is going to have a big impact on society, and there's going to be a lot of funding, I assume. That's always important too. But these are things that this list is things that you might consider doing to get politically involved. But my bottom line here is that I would urge you not to be a wallflower and not to be, as they say, the guy with the green eye shade in the corner office over there, but to be actually out there talking with people, writing white papers, op-ed pieces, and you'll get some flack. No question about it. You'll get flack from various angles, maybe from engineers or maybe from politicians. But I used to worry about that flack quite a bit, but after a few years I realized that was, to me at least, it was a measure of my success, the fact that I was being taken seriously. And as long as I was telling the truth, as defined by me, that was okay. Thank you very much.